Okay, for this problem I want to find the inverse Laplace transform of this given function here. And what I'll write is my f of s here is e to the minus 6s times g of s, where g of s here is 1 over s squared minus 2s minus 8. I want to do that because then my little f of t is going to be u t minus 6, g of t minus 6, where g of t is the inverse transform of g of s. So I have to find the inverse transform of this fraction here. Well, rational function, I should say. And for that, I'm going to have 1 over s squared minus 2s minus 8. Well, this factors down here, okay? So this is 1 over s minus 4 times s plus 2. But I know I can write this as some a over s minus 4 plus b over s plus 2 by the theory of partial fractions. There's constants a and b that will make this work. Well, how can I find a and b? The first step is to clear the fractions here by multiplying throughout by s minus 4 times s plus 2. And so we get 1 equals a times s plus 2 plus b times s minus 4. Right? Because when I'm multiplying this denominator there, everything cancels. I get 1. Here the s minus 4's cancel and the s plus 2 survives. And here the s plus 2 cancel and the s minus 4 survive. And now I can multiply this out and equate coefficients. You may have done it that way before. Or I can choose my s carefully and get these constants a and b quite easily. So this should work for s equals 4. Then I have 1 equals a times 6 plus b times 0. So I get a equals 1/6 from that. And then also I could let s be negative 2 if I wanted. I'll get b equals negative 1/6. Okay? So our 1 over s squared minus 2s minus 8 is 1/6 times 1 over s minus 4 minus 1/6 times 1 over s plus 2 here, right? Okay, so this is easy to take the inverse transform of. I'm going to have my little g of t here is going to be 1/6 e to the 4t minus 1/6 e to the minus 2t. And so finally, so my f of t that I was interested is this u of t minus 6 times g of t minus 6. So this is going to be u of t minus 6. Then I have a 1/6 e to the 4 times t minus 6 minus 1/6 e to the negative 2 times t minus 6. Okay, and that would be